Hi, everyone, and welcome back. It's Kira Garfolo again with Greenville Tech's Math 109. Today, we're going to talk about section 3.4, which is piecewise and power functions. So what are piecewise functions? Well, a piecewise defined function is basically broken down into chunks. It's a function that's broken into several pieces of domain, and each domain has its own separate formula. You can think about a graph being pieced together, hence the term piecewise. We have different pieces that we're kind of gluing together on a graph. It's a collage of graphs, if you will. I have a toddler, well, a 4-year-old, who's very much into graphs or very much into collages and arts. She would like to be into graphs. She loves to draw on graph paper. But basically, think about collages back in your grade school days. So, to find the value of a piecewise function, or if we're going to use a piecewise defined function, we need to be careful with our steps. It's really not any harder than basically evaluating a function, except we have to take the extra step of picking the domain chunk using the conditions that are given. So where does the x value that you're evaluating lie? Which equation should you actually use? You're going to use that one that you picked to plug in your value, and voila, that's all that you need to do. Okay? Basically, taking the math out of it, find where your x goes and plug it into that equation. You only have to do it once for each value, right? If you're given a piecewise equation, it may have 100 different equations for 100 different pieces of the domain, but you only need to evaluate it where your domain, which piece of the domain your x value lies within. Now, if I've royally confused you, this is easier to do through an example, I promise. So let's consider this piecewise defined function here. We have f of x is equal to negative 2x plus 4 if 0 is less than or equal to x is less than 2, or x squared over 2 if 2 is less than or equal to x. So first, we want to find f of 1. If we're going to find f of 1 here, we need to see where 1 is. We see that 1 lies here in this interval right here. So we're going to use the first one. So we're going to have 2 times negative 2 times 1 plus 4, which is going to give us a value of 2. That's our answer. F of 1 equals 2. Now I want you to pause and take a moment and do these rest. I'll give you a second to pause. Okay, to find f of 2, we need to see where 2 belongs. Now be careful here. This is strictly less than. It's this one that includes 2. So 2 is less than or equal to x. So we need to use that second one. So we're going to have f of 2 is going to be 2 squared over 2, which is 2. To find f of 3, we're going to still use that second chunk because 3 is greater than 2. So we're going to have 3 squared over 2, which is going to give us 4.5. And then f of negative 1. Notice here that our graph is only defined, our function is only defined from 0 on up to infinity. So negative 1 does not exist. It's not defined anywhere here. So we would say that it is not defined or it does not exist. Okay? Now, to graph a piecewise function, a lot of people have fun with this. Some people think it's tedious and annoying. I personally think it's kind of fun. Basically, you're going to graph, you're going to put together that collage, okay? You're going to graph each chunk on its own domain. So what a lot of people will do is draw little dotted lines. Make sure they're dotted because they don't really exist if they're dotted on a graph, right? To help you keep that domain straight. You want to mark your endpoints very carefully. So remember that your open endpoints are for strictly less than or greater than, and your closed endpoints are inclusive or when they have those equals to signs included. I like to start in my endpoints because it gives me, that good starting point. It gives me a place that I know I'm starting and finishing with my graph. So let's talk about our earlier piecewise function, okay? So we have a different domain here from 0 to 2 and then from 2 above. We have nothing before that, so we really don't need to graph much over there at all, okay? So if we have 1, 2, like I said, I will often put a little dotted line here to note, hey, that's where my domain is shifting. So when x is 0, I'm going to have 4, and it's going to be a closed dot. It's a linear function, so if I look at 2, negative 2 times 2 is going to be negative 4 plus 4 is going to be 0, so I'm going to have an open circle at 0. And my graph's going to look something like that. Okay. Now, for my next piece is 2 and beyond. When I plug 2 in, I'm going to get 2 squared over 2, which is going to give me 4 over 2, which is going to be just 2. And it's going to be a dot. Okay. And then I can plot some other points. I had 3 was what, 4.5, something like that. And it's going to be a parabola because it's that quadratic. Okay. So it's going to go on upwards from there. We can see here my instructions. They're there for your reference later. But remember that we're first going to graph this. Make sure that you have an open point down there. And the second chunk is a parabola. I've probably overwritten some of the graph here. I would certainly plug in additional values other than your endpoints, particularly this linear function that we have first. You have 2 points, draw a straight line. But the parabola, you're probably going to need some extra points. Okay. Graph as many as you need. Just make sure you stay in the right piece of the domain. If we see what it actually looks like, drawn not by somebody with terrible handwriting, this is what you're going to get. So we have this linear piece. We have nothing to the left of 0. We have this linear piece. Notice this open hole here and closed there in line with our signs. Now I want you to pause and take a few moments to do this one. Okay, so first we're going to find f of -2, f of 0, and f of 3. I have the answers typed out here, but let's walk through it. F of -2 is -2 is less than 0, so we're going to have negative -2. So it's going to be -2 is going to be 2. 0 is just going to be 0 because we're in the second chunk. And f of 3 is greater than 0, is just going to be 3. Okay, so we have that here. If we want to graph it here, 0 we know is at 0, it's a closed dot. We know that f of -2 is 2. We could put that dot there. And we know that f of 3 is 3, which is right here. Okay. This is actually we're gonna see here in a minute, it's our absolute value function. It's a V shape. Okay. You could plot as many more points as you needed to here to get the graph. Okay. Some of you may be able to do it with just those points. Some of you may need a few extra points. Now, a special case of a piecewise function is called the greatest integer function. You may see it as kind of the floor function. It is a step function because when we graph it, we'll see that it looks just like steps. Okay. Our notation is these 2 little half brackets on each side. Okay. So 2 little half brackets on the left, 2 little half brackets on the right. That's kind of how I draw them with X. But when you see that, you're talking about the greatest integer that is less than or equal to X. Okay. So if you're talking about a positive number, you're just looking for that whole number. Where we have to be careful is our negative numbers because we want less than. Okay. So a number that is less than a negative number is larger in magnitude. So kind of keep that in mind as we go through examples. So for example, the greatest integer function for 6.8 is just going to be 6. Okay, because the biggest whole number that we have there is 6. Here's a case of what I was talking about with the negatives. Greatest integer for -4.7, the largest integer is -5. Okay, because -4 is not less than -4.7, it is actually greater than. So we need to make sure that we are less than. If you draw it on a number line, I find that it's simpler. Okay, so you have 0, 1, 2 here. Let's say we were looking at 1.6. Well, look to your left and see the greatest whole number. Look to the left, your first whole number is 1. If we have negative 1.6 here, then we look to the left and we have negative 2. Okay, so think about that. If it helps you to draw it on a number line, draw it and always look to the left. What's the whole number to your left? Okay, so here for negative 4.7, it would be negative 5. And for a whole number, it's just itself. The greatest whole number that's less than or equal to 12 is 12. So we can just go with that. Here's what it looks like on a graph. Remember that we have that equal to piece, so that's where the hole is closed, and then we have up to but not including, so that's where the number jumps from that open hole. So between 0 and negative 1, the value is 0. Between 1 including 1 up to 2, it's 1. 2 up to 3, it's 2. So these are, all the way up to 2.99999, the value is 2. And it's steps. That's why it's called a step function. Okay. Absolute value equations are next. And absolute value, you guys have probably seen this in a previous class, is when we have these two vertical bars surrounding f of x. So when we have an absolute value of some function equals a, or equals some number, we can follow these rules to solve. If a is a positive number, okay, so positive, your absolute value, blah, 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 equals a positive number, you need to solve it twice. You're going to solve it once for the positive value of a and once for the negative value of a. Because remember, the absolute value only cares about the magnitude. It's going to drop that negative for you. If your value of a, so if f of x is perfectly equal to 0, just solve f of x equals 0. That's your solution. Now, if a is negative here, okay, there is no solution. Because remember, an absolute value on its own cannot be negative. So there would be no solution in that case. Let's look at some examples. Let's first solve the absolute value of x minus 2 equals 6. Well, we're going to have to solve this one twice. We're going to have to solve it for x minus 2 equals 6 and for x minus 2 equals negative 6. Okay. So x minus 2 equals 6 is going to give us 8. And x minus 2 equals negative 6 is going to give us negative 4. So our two solutions are 8, negative 4. And if you go back and plug these in, 8 minus 2 is positive 6. Its absolute value is 6. Negative 4 minus 2 is negative 6. And absolute value makes it positive 6. So our answers are correct. It's always a good idea. I know I always say that, but it is very much a good idea to check your work in absolute value. Plug them back in and make sure it makes sense. Now I want you to pause and try this one. This one's a little bit more complicated because we have a quadratic, so pull in what we did at the start of Unit 2. When you're ready, you can unpause. Okay, so we still have an equal 6. So we're going to need to solve it twice. We need to solve it once for x squared minus 5x equals 6. And we need to solve for x squared minus 5x equals negative 6. Solving these with quadratics, you're going to pull everything to one side, or perhaps you're going to use your calculator, whatever you need to do or are allowed to do on that particular problem. So our first one we're going to have for positive 6. These are both easy to factor. So x squared minus 5x minus 6 equals 0. We're going to get 6 and negative 1 for that step. X squared minus 5x plus 6 equals 0 is going to factor into these factors and give us the answers of 3 and 2. So we have 4 possible answers here, because remember that each quadratic has 2. And so we're going to have negative 1, 2, 3, and 6 as our possible answers. If you didn't get that right away, that's okay. Take a moment, pause, rewind, do what you need to do to digest. So be sure to get some practice here. A lot of students find piecewise defined functions to be interesting, but weird nonetheless, okay? It's not necessarily intuitive to put all of those together. Get your practice, use your resources. Remember that our publisher has lots of resources online through your homework, extra practice problems. There's videos and multimedia. There's all kinds of stuff. Remember the departmental lecture notes are available, and there's lots of examples and extra problems in your text. Remember to reach out if you need help. Have a great day, and I hope to talk to you guys next time.